On July 14, 1941, at a rail junction near the city of Orsha in western Russia, Captain Ivan Flerov received an order that had never been given to any artillery officer in history. He commanded 7 vehicles, trucks with metal rails welded to their beds, each rack holding 16 rockets pointed skyward at a fixed angle. The weapon had no official designation. His men were permitted to speak aloud. The documents called it the BM-13. The crews called it Katyusha, after a wartime song about a girl waiting for her soldier to come home. Flerov aimed his vehicles at the German supply depot and the rail infrastructure the Wehrmacht had been using to push men and material eastward since the invasion began 3 weeks earlier. He gave the order to fire. Each vehicle discharged its 16 rockets in under 10 seconds. The rockets left the rails with a sound that witnesses described as a howl. Not a bang, not a whistle, but a sustained mechanical scream that built from the first launch and did not stop until all 112 rockets were in the air simultaneously, arcing toward the depot below a trail of fire and smoke. The noise was unlike anything artillery had produced before. The 132mm warheads arrived in a pattern that covered an area no conventional battery could saturate in a single volley. The depot burned. The rail junction ceased to function. The German soldiers in the area had no training for this. Their doctrine covered artillery, mortars, bombs. It did not cover a sound that came from nowhere, grew louder for 10 seconds, and then delivered destruction across several hundred meters in one instant. Several accounts from German units near Orsha that day described men leaving their positions before the rockets had landed, not in response to the impacts, but in response to the sound. The weapon that produced that sound on July 14, 1941, was Soviet in design and Soviet in operation. But the principle behind it, the idea that an unguided rocket fired in mass could terrorize as effectively as it destroyed, that accuracy was less important than volume, that the sound of a weapon was itself a weapon, that principle was British. It was 137 years old, and when it was first proposed in London, the Army called it ridiculous. If you're enjoying the story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. William Congreve was 32 years old in 1804 and had never heard a Mysorean rocket in flight. He had only read about them in the reports coming back from India, where the East India Company had been fighting Tipu Sultan, the ruler of Mysore, for the better part of 2 decades. Tipu Sultan's rocket men were a specialized corps, 5,000 of them, organized into units of 200 assigned to each brigade, carrying iron-cased rockets that could reach targets 1,000 yards distant and carried incendiary payloads that stuck to whatever they hit and burned. The British officers in India were not impressed by the rockets initially. They were inconsistent. Some flew straight. Some curved unpredictably. The psychological effect on horses was severe. The animals panicked at the sound and the fire, but on disciplined infantry behind earthworks, the impact was more variable. After Tipu Sultan died in the siege of Seringapatam in 1799, the British collected dozens of his rockets and shipped them to Woolwich Arsenal, where they sat in a storeroom for 5 years while no one knew what to do with them. Congreve knew what to do with them. His father was a comptroller of the Royal Laboratory at Woolwich, which meant Congreve had access to the arsenal's facilities and to the stored Indian rockets from childhood. He had studied them. He understood, in a way the institutional army did not, that the rocket's value was not precision. Their value was fire, speed of delivery, and noise. A single rocket landing near a position was an annoyance. 100 rockets landing within 10 seconds, each carrying an incendiary charge that scattered burning composition across a wide area, was something different, something that could set a city alight before any conventional battery could range in. He began experimenting with his own money. The early results were not encouraging. The best commercial rockets in London in 1804 had a maximum range of 600 yards. Congreve worked to the winter of 1804 and 1805 redesigning the casing, the propellant charge, and the stabilizing stick. The Indian rockets in the Woolwich storeroom were his reference point. The Mysorean design used an iron cylinder packed with propellant mixture that burned more consistently than European gunpowder rockets, and a bamboo stick attached to the casing that stabilized the flight by acting as a counterweight. Congreve kept the iron casing, replaced the bamboo with a straight wooden stick of his own calculation, and varied the propellant composition systematically until he found a mixture that produced reliable thrust without the erratic burning that had made the earliest rockets turn mid-flight and head back toward the crew. By the spring of 1805, he had a rocket that could reach 1,500 yards reliably and in the same general direction it was pointed. He petitioned Lord Chatham at the Ordnance Department for permission to scale up. The petitions were not well received. Lord Chatham's response was to send Congreve's proposal to the Master General of the Ordnance, who sent it to the senior artillery officers for assessment. The artillery officers produced a report noting that the rocket's accuracy was insufficient for military purposes, that the propellant was hazardous to handle and store, and that the existing artillery establishment could already deliver effective indirect fire against most targets that a rocket might be used against. The report recommended no further development. Congreve appealed over their heads. The precedent for doing so existed. Inventors in England, who believed their work had been improperly dismissed by one department, could petition directly to a senior royal patron. Congreve petitioned the Prince of Wales. The prince expressed interest. The Navy, which had fewer institutional commitments to the howitzer than the Army, and which saw a possible use for the rocket in ship-to-shore bombardment, agreed to conduct sea trials. The Ordnance Department was not enthusiastic. The Royal Artillery had spent 2 centuries developing precision indirect fire, the mathematics of ballistics, the careful calculation of elevation and charge, the trained eye of the officer adjusting shots by observation. All of this was the foundation of what the artillery considered its professional identity. A weapon that could not be accurately aimed, that flew on a trajectory shaped by the burning of its propellant rather than precise setting of a gun barrel, was not artillery. It was fireworks. Senior artillery officers said so in those terms in writing. Congreve did not argue with the Ordnance Department. He demonstrated. In November 1805, he arranged a test firing at Woolwich that sent rockets across the Thames at ranges the artillery present had not expected. He applied directly to the Prince of Wales, bypassing the institutional resistance. By early 1806, the Navy had agreed to trial the weapon in combat conditions. The Army's position was that the thing was impractical, and its proponent was an amateur who happened to have a well-placed father. The personal dimension of Congreve's campaign mattered because it shaped how the Army received whatever the weapon subsequently achieved. William Congreve was the son of privilege. His father's position at Woolwich had given him access that no ordinary inventor would have had, and the senior artillery officers who opposed the rocket knew this and resented it. They were professionals who had spent careers learning a precise mathematical discipline. Congreve was a gentleman amateur who had spent a year rebuilding someone else's invention in a government workshop he could access because of his father. The professional resentment of the amateur's success was a feature of every British Army assessment of the rocket from 1805 through 1815. What the professionals missed was that Congreve understood the rocket's specific advantage more clearly than they did. He was not trying to compete with a howitzer. He was trying to do something no howitzer could do. Set a large area on fire in 30 minutes with a crew of 20 men and equipment that could be loaded on 6 wagons. The howitzer's precision was irrelevant to that task. The rocket's imprecision was irrelevant to it too. What mattered was volume, speed, and fire. On the night of October 8, 1806, 24 small British warships approached the French harbor of Boulogne and fired 2,000 Congreve rockets into the town in approximately 30 minutes. Boulogne burned. The fire spread to the harbor district and destroyed a section of the town that conventional naval bombardment had failed to reach in previous engagements. The French casualties were not extraordinary, but the fire damage was, and the speed at which 2,000 projectiles had been delivered onto a target in half an hour was unlike anything any European military had encountered in the modern era. Congreve submitted his after-action report. The Army remained unconvinced. The inaccuracy of individual rockets meant that precision targeting was impossible. You could set a town on fire, but you could not hit a specific position within it. Against disciplined troops in earthworks, the weapon was of questionable value. The Army's objections were not wrong. They were simply measuring the wrong thing. Congreve's argument, which he made repeatedly through correspondence and published pamphlets, was that the rocket's value was not in what any single one could do. It was in what a large number of them could do simultaneously. No conventional battery could deliver 2,000 shells onto a target in 30 minutes. The The mathematics of powder charges and cooling barrels made mass delivery impossible at the speed rockets permitted. The individual rocket was imprecise. The salvo of rockets was a different instrument entirely, an instrument of area destruction, of fire, and of psychological disruption that had no equivalent in the artillery's repertoire. In 1807, the Navy put this argument to its most dramatic test against the Danish capital of Copenhagen. Held by a neutral power that Britain feared Napoleon might co-opt, a British force landed, and after preliminary diplomatic exchanges that produced no Danish capitulation, fired approximately 40,000 Congreve rockets into the city over 3 nights, combined with conventional bombardment. Copenhagen burned. The Church of Our Lady lost its tower. Entire districts were destroyed. An estimated 2,000 Danish civilians died. The Danish fleet surrendered. The Copenhagen bombardment was the first time in the modern era that a city had been systematically destroyed by rocket fire. The moral revulsion it generated across Europe was immediate and lasting. The attack on a neutral capital was widely condemned, and Congreve's weapon was associated with the atrocity as much as with the military achievement. Wellington, who was not present but observed the results, made his position clear when asked about using rockets in his own campaigns. He did not want to set fire to any town, he said. He did not want to destroy what he was supposed to be liberating. The Duke used the weapon eventually. At Leipzig in 1813, British rocket troops attached to the coalition forces fired salvos against French positions on the Lindenau Road. At Waterloo in 1815, the 2nd Rocket Troop of the Royal Horse Artillery deployed on the right flank. The rockets contributed to the confusion of the French cavalry and were credited by some officers with delaying a critical advance. Wellington acknowledged the use, said as little about it as possible, and never publicly modified his assessment of the weapon's value. Wellington's use of the weapon at Waterloo was reluctant and limited. The 2nd Rocket Troop of the Royal Horse Artillery, commanded by Captain Edward Wingate, was attached to the right wing of the Allied line. Wellington had agreed to include rocket troops in the order of battle only on the condition that Wingate's unit also brought conventional guns. The Duke was not willing to rely on the rockets alone for any specific tactical task. When the rockets were fired at French cavalry during the battle, the trajectory of several was described by British infantry nearby as disconcertingly close to their own positions. Wingate himself was wounded during the engagement. Wellington's post-battle assessment of the weapon's contribution was not preserved in any positive form. What Wellington understood, and what ultimately defeated the Congreve rocket as a British military instrument, was that the rocket's limitation was not just technical but logistical. A rocket brigade required enormous quantities of propellant that was sensitive to moisture, a train of wagons for the rocket bodies, and crews whose operating procedures were so different from conventional artillery that they could not be integrated into existing regimental structures. A howitzer battery could do everything a rocket battery could do in terms of fire support, less the area of incendiary capability, and it could do it with greater accuracy, greater reliability, and within an existing chain of command that every officer in the Army already understood. The rocket offered one thing no howitzer could: the ability to set a large area on fire very quickly. In colonial warfare, where the opponent was often not an earthworks and where the psychological shock of fire was a legitimate military tool, the rocket had occasional value. In European warfare against disciplined armies behind fieldworks, it was of marginal use. By the 1860s, the British Army had effectively retired the weapon. The idea lived in the technical literature. It lived in the Woolwich Arsenal's records. And it was read carefully by engineers in Russia in the 1920s who were trying to build a weapons program from institutional memory and capture documents. If you have watched this far, you already know where this story goes. What the British called ridiculous in 1804 was raining fire on German positions in 1941. Subscribe now if this is a kind of history that deserves more than one telling. It costs nothing, and we will be here when you come back. The Soviet rocket program began seriously in 1921, when the Gas Dynamics Laboratory in Petrograd started work on solid-fuel rockets for military applications. The researchers who built that program knew the Congreve rocket. It was in the European technical literature and had been studied by Russian military theorists for decades. They also knew, from the experience of the First World War. That artillery's primary limitation was not lethality, but speed of delivery. A howitzer battery that could range in on a target and begin effective fire in 20 minutes was tactically valuable. A weapon that could deliver the equivalent of a full battery's fire in 10 seconds, covering the same area, was tactically transformative. By 1938, the Gas Dynamics Laboratory had developed the RS-132 rocket, a 132mm solid-fuel unguided rocket that could carry a 9-kilogram explosive warhead, approximately 8 kilometers. The challenge was not the rocket, but the launcher. A single rocket fired from a handheld tube was Congreve's problem all over again. Unpredictable single shot, requiring a crew exposed during preparation. The solution was the same one Congreve had implicitly understood up alone. Rails, multiple parallel rails, angled at a fixed elevation, loaded with rockets that could be fired electrically in sequence or simultaneously. Mount the rack on a truck. Drive the truck to the firing position. Connect the electrical circuit. In 10 seconds, deliver 16, 24, or 36 rockets onto a target area that a conventional battery would need 3 minutes and multiple ranging shots to strike. The engineers who built the BM-13 launcher, Georgy Langmack, Vladimir Artemyev, Andrei Kostakov, and their colleagues at what had by the late 1930s become the Jet Propulsion Research Institute, had spent the better part of a decade working on this problem. Langmack had joined the Gas Dynamics Laboratory in 1928. He had read the Congreve literature. He understood the basic principle. What he and his colleagues contributed was not the concept, but the engineering. The specific alloy of the rocket casing that could handle propellant burn without deforming. The electrical firing system that could discharge rockets from multiple rails in sequence within a defined time window. And the carriage design that could be fitted to a standard military truck without requiring significant structural modification to the vehicle. Langmack did not live to see the weapon used in combat. In 1937, he was arrested during Stalin's purges, accused of counter-revolutionary activity on fabricated evidence, and executed on January 11, 1938. He was 41 years old. His name was removed from the project records. The colleagues who continued his work did not mention him. The BM-13 that Ivan Flerov drove to Orsha in July 1941 was built on Langmack's engineering, but his contribution was classified, suppressed, and not acknowledged until 1991, when the Soviet government posthumously rehabilitated him and awarded him a Hero of Socialist Labor 53 years after his death. The Red Army's artillery branch did not want it. The objections were the same ones the Royal Artillery had raised about Congreve in 1806. The rocket was inaccurate. The reload time was excessive, up to 50 minutes to reload a full rack, and the visibility of the launch, a streak of fire and smoke visible for miles, would give away the launcher's position and invite immediate counter-battery fire. A conventional howitzer battery could fire 90 to 100 rounds in the time a Katyusha battery needed to reload. On those terms, the Katyusha was inferior. The argument for the Katyusha, as for the Congreve rocket, was not that the individual round was more effective. It was that the salvo was more effective. 16 rockets landing in the same area within 10 seconds created an effect that no conventional battery could replicate. Not because the total weight of explosive was greater, but because the density of impact in a short time produced a different kind of destruction. Structures that could survive a conventional barrage because they were hit by shells at intervals, allowing dust to settle, fires to be controlled, wounded to be moved, could not survive 16 rockets in 10 seconds. There was no interval. The strikes were simultaneous. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. And there was a sound. The RS-132 rocket burned its propellant for approximately 0.4 seconds after leaving the rail. At launch, the burning propellant produced a jet of flame and a characteristic howl that German witnesses consistently described as unlike any other weapon they had encountered. The howl built over the 10 seconds of the salvo, each successive rocket adding to the noise until the last one left the rail. Then the rockets were in ballistic flight, silent, invisible in the dark, and the sound shifted to the scream of their passage overhead, a rising tone that lasted 3 to 4 seconds before the impacts began. The total sonic experience lasted approximately 15 seconds. It was unlike artillery, whose single reports were brief and whose sound was the crack of discharge rather than a sustained animal noise. It was unlike bombs, which arrived without warning. It was a sustained, growing, identifiable sound that gave German soldiers exactly enough time to understand what was coming, and not enough time to do anything about it. Captain Flerov's battery at Orsha was not the only thing that made July 14th, 1941 significant. The German High Command received reports from the engagement within hours. The reports were consistent. A new Soviet weapon, truck-mounted, firing multiple rockets simultaneously, producing a sound that was causing troops to break position before the warheads had even landed. The requests from field commanders for guidance on how to defend against it were almost identical from multiple sectors. No one had doctrine for sound. The German name for the weapon emerged from the troops rather than from any headquarters. They called it the Stalinorgel, Stalin's organ, because the rows of launch rails on the back of the truck, angled upward in parallel rows, looked like the pipes of a pipe organ, and because the sound it produced when firing suggested to soldiers with some musical education the kind of sustained chord a massive pipe organ could produce in a cathedral. The name stuck. It spread to the Wehrmacht's Eastern Front formations faster than any official communication. Within weeks of Orsha, German soldiers who had never seen a Katyusha understood what the name meant. Some had nightmares about the sound before they had ever heard it. A second nickname emerged in some units. The Katyusha was also called the Stalinorgel because of the visual appearance of the rockets leaving the rails simultaneously. The jets of fire from 16 propellant burns at once, rising from the truck bed at a fixed angle, looked from a distance like the light show of a massive instrument. The dual origin of the nickname, from the visual and from the sonic, suggests that both the appearance and the sound of the weapon were equally distinctive. German units that encountered the Katyusha consistently described both in their after-action reports, as if no account of the engagement was complete without specifying that they had seen the fire from the launch and heard the howl that followed it. The Soviet secrecy around the weapon initially matched the German fear of it. The BM-13 launchers were operated by NKVD special units in the war's first months, not by regular Red Army artillery. The crews were sworn to secrecy about the weapon's technical details. Officers were issued a specific order. If capture appeared imminent, the launcher was to be destroyed. Several early launchers were blown up by their own crews to prevent capture. The Germans found the wreckage, collected the rocket fragments, and sent them to their own engineers. The reverse engineering was straightforward. The RS-132 rocket was not technically complex, but the manufacturing capacity to replicate the system was a different problem. The secrecy also produced a specific kind of confusion among Soviet soldiers who encountered the weapon without being briefed on it. Accounts from the summer of 1941 describe Red Army infantrymen who witnessed a Katyusha battery fire for the first time and had no framework for what they had seen. One account from a political officer attached to a guards unit describes infantrymen who assumed the fire and sound were from German aircraft and took cover accordingly. When they were told the sound had been their own weapon firing, several of them refused to believe it. A Soviet howitzer sounded like a howitzer. Nothing in their experience had prepared them for what a Katyusha battery firing at full salvo sounded and looked like from a distance of several hundred meters. The Nebelwerfer, the German rocket launcher that appeared on the Eastern Front in significant numbers from 1942, was a response to the Katyusha. German soldiers called it the Heulen-Kuh, the mooing cow, for its own distinctive sound. It was technically more accurate than the Katyusha and had a somewhat faster reload time, but it was towed, not truck-mounted, which limited its tactical mobility, and it was produced in smaller numbers. The Katyusha's key advantage was not technical superiority. It was production volume and platform mobility. You could build a Katyusha launcher in a light industrial facility. You could mount it on any truck capable of carrying the rail frame. By the end of 1942, 3,237 Katyusha launchers had been produced. By the end of the war, the total exceeded 10,000. A significant number of those launchers were mounted on Lend-Lease trucks. British and American vehicles shipped to the Soviet Union under the supply agreement that sent hundreds of thousands of trucks eastward from 1942 onward. The Studebaker US-6 became the preferred platform for the BM-13, stable enough for the recoil of a full salvo and mobile enough to reposition before German counter-battery fire could range in. Launchers on British Lend-Lease trucks were designated BM-13s. The weapon that descended from William Congreve's experiments at Woolwich Arsenal was mounted on British trucks, firing on German positions, named after a Russian song, and called by German soldiers the most terrifying sound they had ever heard. The battles where the Katyusha mattered most were not the single first strike at Orsha. The weapon's real significance was in a mass deployment that came with the Soviet offensives of 1943 and 1944, when the Red Army had rebuilt its artillery arm and learned to use rocket artillery as the Congreve logic demanded, in quantity, in coordination, and at the moment when mass delivery onto a specific area was more important than precision. At Kursk in July 1943, Soviet defensive preparations included mass Katyusha batteries positioned to cover the approaches the German assault divisions had to cross. When Operation Citadel launched on July 5th, the German assault formations moved through a landscape where the approach routes had been registered by Katyusha batteries whose fire was coordinated with a conventional artillery barrage. German infantry and armor crossing the open ground between the tree lanes encountered Katyusha salvoes that arrived without the conventional warning sound of howitzer fire. The howl was the only warning. The impacts followed the howl. German memoirs from Kursk soldiers who survived describe learning a specific physical response to the Stalinorgel sound, a reflex dive to the ground, regardless of what you were doing, regardless of whether there was cover. Men who had been trained and disciplined to maintain position under conventional artillery fire described abandoning that discipline completely in response to the Katyusha sound. It was not rational. A man lying flat in the open was not significantly safer than a man crouching in a shallow foxhole, but it was universal. The sound produced a specific, total, involuntary response that conventional artillery did not. Guy Sager, an Alsatian soldier who served in the Grossdeutschland Division on the Eastern Front and later wrote a memoir of his experiences, described the Katyusha in terms that became one of the most cited accounts of the weapon in post-war literature. He wrote that the sound was something between a groan and a howl, that it built from a single voice to a chorus as the salvo progressed, and that the specific quality of it was not the volume, though the volume was considerable, but the duration. Conventional artillery came in individual reports, separated by fractions of a second, allowing the soldier's brain to process each impact as a discrete event. The Katyusha salvo came as a continuous sound that lasted 15 seconds or more, and the brain had no framework for processing something that was simultaneously artillery and not artillery, that was lethal and ongoing, that did not stop. Franz Schneider, a German infantry officer who served on the Eastern Front from 1941 through 1944, described his post-war account sitting in a forward position near Kursk in the summer of 1943, when a Katyusha battery fired for what he estimated was 3 kilometers away. He heard the howl build. He knew what it was. He knew the rockets were in ballistic flight, that the launch sound did not mean they were still accelerating toward him, and he knew that the spread of a Katyusha salvo meant any given soldier was probably not in the exact area of impact. He threw himself to the ground anyway. He could not stop himself. He was still doing so when he wrote the account, still somewhat ashamed of the reflex, and still unable to explain it except by saying that the sound bypassed everything he had been trained to do and reached something underneath training. The German army formally classified Katyusha strikes as a specific category of psychological threat in its intelligence assessments by 1942. Units moving into sectors where Katyusha batteries were known to operate were briefed on the weapon's characteristics in an attempt to reduce the panic response. The briefings had limited effect. Knowing what produced the sound did not prevent the response to it. This was what Congreve had argued in his pamphlets in 1806 and 1807. The rocket, he wrote, was a weapon of terror as much as of destruction. Its imprecision was irrelevant because terror required volume, not accuracy. What mattered was that the target could not locate the source by sound in time to respond, could not estimate where the rockets would land from the trajectory of the first one, and could not control the psychological effect of sustained noise that was unlike any weapon in their experience. The British Army had called him impractical. The German Army, lying face down in Ukrainian earth in July 1943, had arrived at a more informed assessment. The operations from 1944 onward saw the Katyusha in its final and largest deployment phase. The The Bagration Offensive in June 1944, which destroyed Army Group Center and was arguably the largest single military operation of the entire war, was preceded by a preparation barrage that included over 9,000 Katyusha launches in the first hours. The planning for Bagration included specific placement of Katyusha Guards mortar units, the Soviet designation for rocket artillery formations, in positions calculated to saturate the German first and second defensive lines simultaneously. The coordination between the rocket salvos and the conventional howitzer fire was precise. The rockets arrived during the window when German troops had gone aground in response to the howitzer barrage, rising to return fire. The combination of the two, the howitzer suppressing, the rockets landing while heads were down, was a tactical application of everything Congreve had described in his 1806 pamphlet, at a scale he could not have imagined. The sound of the Bagration preparation barrage, across a front of several hundred kilometers, was audible to German positions far enough back that they had no tactical response available. The warning came too early to do anything except wait. Accounts from German positions receiving the barrage described the sound building from individual howitzer fire to a continuous roar that was later overlaid by the characteristic Katyusha howl as the rocket batteries fired in sequence. The total preparation lasted 4 hours in the northern sector. German telephone communications were cut within the first 20 minutes. After an hour, radio communications were failing because the operators were unable to function under sustained barrage. The German command system along the Army Group Center front was effectively destroyed before the Soviet ground assault began. At Silo Heights in April 1945, the final approach to Berlin, the Soviet preparation included over 40,000 guns and rocket launchers firing on a front of approximately 24 kilometers. Marshal Zhukov ordered the preparation to begin at 3 a.m., calculating that the darkness and the massed searchlights he had placed behind the Soviet lines would illuminate the German positions while blinding the defenders. The Katyusha contribution to that barrage, the specific sound of rocket salvos overlaid on the conventional artillery, was what survivors on both sides remembered most clearly decades later. It was, in the words of a German officer who survived the position and was later interviewed by Soviet historians, the sound of the war ending. The weapon that ended the war in Europe in 1945 was a direct descendant of a British invention that British military authorities had called impractical, limited, and fit only for burning towns. Wellington had refused to use it for liberating Europe. His successors had let it fall into disuse. The Soviets had read Congreve's technical specifications, improved propellant, mounted the launcher on a truck, and fired 12 million of them. Ivan Flerov did not survive the war. After the initial success at Orsha in July 1941, his battery was ordered to continue operations in the Vyazma sector as the German advance continued east. By October 1941, the German advance had reached a point where Soviet formations in the Vyazma area were being encircled. Flerov's experimental battery, attached to the retreating forces, found itself cut off. On October 7, 1941, surrounded by German forces following the encirclement at Vyazma, Flerov's battery attempted to break out of the pocket. The column moved at night along roads the Germans had already reached. At some point in the breakout, the exact location was not established until decades later, German forces found the column. When it became clear that the launchers could not be extracted and that capture was certain, Flerov detonated them to prevent their technology from falling into German hands. He was killed in the breakout. He was 31 years old. His battery had carried out the first operational BM-13 strike in history 3 months earlier and had continued operations in the weeks that followed. The men and his crew who survived the breakout were scattered across the encirclement. Some made it through Soviet lines. Some were captured. Some were killed. The records of who did what in the final hours were not assembled until long after the war. He received no state recognition for Orsha during his lifetime. The Soviet government did not acknowledge the BM-13's existence publicly until 1942. NKVD security over the weapons classification extended the suppression of information about its operational use, which meant that even soldiers who had watched Flerov's battery fire at Orsha could not speak about what they had seen. The weapon Flerov had used in the first combat deployment was classified, the engagement was classified, and his death in the breakout was recorded in unit documents that remained inaccessible for decades. The Soviet government issued a Hero of the Soviet Union citation for Flerov in 1963. This was later revised. In 1995, 54 years after Orsha, the Russian government posthumously awarded Ivan Flerov the title Hero of the Russian Federation. A monument was erected at the site of the Orsha attack. The German soldiers who had been at the rail junction on July 14, 1941, had never learned the name of the officer who fired the first salvo. Most of them had never thought about where the weapon had come from. They had only heard the sound. The 7 trucks he had driven to the rail junction at Orsha are long gone. The weapon he fired, the principle that mass rocket delivery creates a terror that no amount of conventional artillery training can prepare soldiers for, is in service of more than 60 armies around the world today. Every multiple rocket launcher currently in military service, from the American MLRS to systems operating in conflicts on 4 continents, is the application of the same argument William Congreve made to the Royal Artillery in 1806 and was told was ridiculous. William Congreve died in 1828 in Toulouse, where he had gone for his health. He was 55 years old. He had spent the last years of his life working on improvements to a weapon that the British Army had largely set aside. His patents on the rocket design were his primary legacy, and the commercial income from them was limited by the Army's decreasing interest in ordering them. He was buried in Toulouse. His grave was discovered and restored in the 20th century, long after his weapon had been adopted by everyone except the Army that had originally dismissed it. Georgy Langmack, who built the engineering that made the BM-13 work, was rehabilitated in 1991 and is now recognized in Russia as one of the principal designers of the Katyusha system. The institute where he worked carries his name. Ivan Flerov received his monument at Orsha. The song Katyusha, after which the weapon was named, is still sung in Russia today. A song about a girl waiting for her soldier, attached permanently to a weapon that howled across 4 years of the most destructive war in human history. The sound the German soldiers called Stalinorgel, the sound that made trained Wehrmacht veterans dive face first into Ukrainian soil without a thought for cover or doctrine or the orders of their officers, was the sound of a British idea that the British had given up on reaching its destination by a different route. Congreve would have recognized what it was doing. Wellington would have disapproved of the method. The German soldiers lying in Ukrainian earth in 1943 had no opinion about either of them. They had only the sound. If you stayed until the end, you understand why this story does not sit in any single national history. The British call it the Congreve rocket and remember it as a colonial-era curiosity. The Russians call it Katyusha and remember the song. The Germans called it Stalin's organ and remember the sound. What none of those national memories fully contains is a through line. The idea that a weapon does not need to be accurate to be decisive, that the salvo matters more than the individual round, that the sound of a weapon arriving is itself a force multiplier that changes what soldiers do before a single warhead has detonated. Congreve argued this at Woolwich in 1805. The artillery officers who told him he was wrong were not stupid men. They were measuring by the standards of their instrument, and by those standards, they were correct. The rocket was less accurate than a howitzer. That was true and remained true until the last Katyusha was fired in 1945. What they were wrong about was the assumption that accuracy was the only thing that mattered. In European warfare in the 19th century, against disciplined armies behind earthworks, accuracy mattered enormously. Against a city full of wooden buildings of Boulogne in 1806, it did not. Against a German supply depot at Orsha in 1941, it did not. Against German infantry massing for an assault at Kursk in 1943, trying to cross open ground before the Katyusha batteries could reload, it did not. The weapon's imprecision was a feature of its design. The terror it produced was a feature of its imprecision, because a soldier who cannot predict where the next rocket will land cannot make a rational decision about where to be. He can only flatten himself and wait. That is a legacy of William Congreve, the gentleman amateur who rebuilt an Indian weapon in his father's workshop and was told by the Royal Artillery that what it made was ridiculous. The Germans lie in the fields of Russia and Ukraine in the years between 1941 and 1945 would not have used that word. Subscribe and tell us where you are watching from. Tell us if someone in your family served on the Eastern Front on either side, or if this story say you're looking for more. The comments section is where the people who know these stories add what the archives missed. If this sent you somewhere new, we will be here when you come back. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.